Hello everybody, today I'll be going through all of the challenge questions in Edexcel's Pure Year 1 textbook, chapter 6. Okay, our first question is from exercise 6a. A triangle has vertices at A 3, 5, B 7, 11 and C P Q. The midpoint of the side BC is M 8, 5. Part A says find the values of P and Q. So, our midpoint of BC is going to be 7 plus P over 2. 11 plus Q over 2, and that is the point M, which is 8, 5. Therefore 7 plus P over 2 equals 8, so P equals 9, and 11 plus Q over 2 equals 5, so Q is minus 1. Part B, find the equation of the straight line joining the midpoint of AB to the point M. So the midpoint of AB is going to be 3 plus 7 over 2, 5 plus 11 over 2, which is 5, 8. And the straight line joining this point to the point M, 8, 5. So the gradient of this line is equal to 8 minus 5 over 5 minus 8, which is minus 1. And so we get y minus y1. Let's choose the point 5, 8, so y1 is 8. Is equal to the gradient times x minus x1, which is 5. And so we get y equals 13 minus x, and that is our answer to part B. Part C says show that the line in part B is parallel to the line AC. So our point A is 3, 5, and the point C is PQ, which is 9 minus 1. And so the gradient of the line joining these 2 points is going to be 5 plus 1 over 3 minus 9, which is 6 over minus 6 and minus 1 again. And we know that the gradient of the line in part B is also minus 1. So as the gradients of the two lines are equal, they are parallel. Okay, our next question is from exercise 6b. The triangle PQR has vertices at P 6, 9, Q 3 minus 3 and R minus 9, 3. Part A says find the perpendicular bisectors of each side of the triangle. So to find the perpendicular bisector, we need to first find the midpoints of the sides and also the perpendicular gradients at each of the sides. So if we start with the midpoints, if we start with the side PQ, midpoint of the side PQ is going to be 6 plus 3 over 2, 9 minus 3 over 2, which is 9 halves, 3. For the side QR, this will be 3 minus 9 over 2, minus 3 plus 3 over 2, which is minus 3, 0. And finally, the side RP, we will have minus 9 plus 6 over 2 and 3 plus 9 over 2, which gives us minus 3 halves, 6. Okay, now we can find the perpendicular gradients. So for PQ, the gradient of PQ is going to be 9 plus 3 over 6 minus 3, which is 4. So the perpendicular gradient is going to be minus 1 over 4. And doing the same for QR, we will have minus 3 over 3 plus 9, which gives us minus a half. So our perpendicular gradient is 2. And finally, RP, we have 3 minus 9 over minus 9 minus 6, which is minus 6 over minus 15, so we get 2/5. So our perpendicular gradient is minus 5 over 2. Okay, now we can find the equations of the perpendicular bisectors. So first, looking at PQ, using the general form of the line, we have y minus y1 is equal to the gradient x minus x1. So expanding out the minus a quarter and adding the 3 to the other side, get y equals negative a quarter x plus 9/8 plus 3, so we get plus 33 over 8. Now for QR, we have y minus y1, which is 0, is equal to the gradient 2 x minus x1. So we have y equals 2x plus 6. And finally, for our p, we have y minus y1 is equal to the gradient minus 5/2 x minus x1. And so we get y equals minus 5/2 x, and we have minus 15 quarters plus 6. So we have 9 quarters. And these three equations are our perpendicular bisectors. Okay, now we have the three equations of our perpendicular bisectors. Part B says show that all of these bisectors meet at a single point and find the coordinates of that point. So we can take any two of these equations. So I'm just going to take the top two and we can solve them simultaneously. So we get minus a quarter x plus 33 over 8 is equal to 2x plus 6. So rearranging, we get 9 quarters x is equal to 33 over 8 minus 6, which is minus 15 over 8. And so we get x equals minus 5 over 6. Now plugging that back into the second equation, we get y equals 2 times minus 5 over 6 plus 6, which equals 13 over 3. So the coordinates of the point of intersection is minus 5 over 6, 13 over 3. Now, all we have to do now is check that this point lies on RP. So, plugging in the value of x to the right hand side, we get minus 5/2 times minus 5 over 6 plus 9 quarters, which gives us 13/3, which is y as we required. So therefore, we have shown that all three meet at a single point, and the coordinates of that point is minus 5 over 6, 13/3. Okay, our next question comes from exercise 6c. Question 1 says a circle with the equation x minus k squared plus y minus 2 squared is equal to 50 passes through the point 4 minus 5. Find the possible values of k and the equation of each circle. So we can substitute this point straight in. So x equals 4. We have 4 minus k squared and y equals minus 5. So we have minus 5 minus 2 squared is equal to 50. Therefore 16 minus 8k plus k squared plus 49 is equal to 50. And therefore k squared minus 8k plus 15 is equal to 0. And we can factorize this to get k minus 3, k minus 5 equals 0, and therefore k equals 3 or k equals 5. So the first possible equation of the circle is x minus 3 squared plus y minus 2 squared equals 50, and the second one is x minus 5 squared plus y minus 2 squared equals 50. And those are our answers. Okay, our next question, question 2. By completing the square for x and y, show that the equation x squared plus y squared plus 2fx plus 2gy plus c equals 0 describes a circle with centre minus f minus g and radius f squared plus g squared minus c. So we can rearrange this equation to a more friendly form for completing the square. So we have x squared plus 2fx plus y squared plus 2gy is equal to minus c. Now, if we complete the square, we will get x plus f squared, and then we have to take away the extra f squared, and then we'll have y plus g squared, and we have to take away the extra g squared equals minus c. Taking the f squared and g squared onto the other side, we get x plus f squared plus y plus g squared is equal to f squared plus g squared minus c. And therefore we can see that the radius of the circle is the square root of f squared plus g squared minus c. And also the centre of the circle is minus f minus g, as required. Okay, our next question is from exercise 6e. Question 1. The circle C has equation x minus 7 squared plus y plus 1 squared is equal to 5. The line L with positive gradient passes through 0, minus 2 and is a tangent to the circle. Find an equation of L, giving your answer in the form y equals mx plus c. So, the first thing we can spot is that the line L has a y-intercept of minus 2. So we can write the equation for L in the form y equals mx minus 2, and that will help us simplify things a little bit. Right, so we know that the line L only intersects the circle at one point, and so if we find the points of intersection by solving the two equations simultaneously, we should only get one solution, and hopefully we can use that to find m. So, if we solve these two equations simultaneously, if we plug in y equals mx minus 2 into the equation for the circle, we get x minus 7 squared plus mx minus 2 plus 1, so minus 1 squared, is equal to 5. So we get x squared minus 14x plus 49 plus m squared x squared minus 2mx plus 1 is equal to 5. And so, collecting terms, we get 1 plus m squared x squared minus 14 plus 2mx plus 45 is equal to 0. And we know that there must be only one solution because the line is a tangent, so there's only one point of intersection. So we can use a discriminant, b squared minus 4ac, and we know that must be equal to 0. So we have 14 plus 2m, minus 14 plus 2m all squared, minus 4 times 1 plus m squared times 45 has to be equal to 0. So, expanding our brackets here, we get 4m squared plus 56m plus 196 minus 180 minus 180m squared equals 0. Okay, and collecting like terms, we get minus 176m squared plus 56m plus 16 equals 0. And plugging this straight into your calculator, we should get that m equals minus 2 over 11, or m equals a half. And from the diagram, we can see that m must be positive, so you can reject this answer, and m equals a half is our final answer. Okay, question 2. The circle with centre C has equation x minus 2 squared plus y minus 1 squared equals 10. Tangents to the circle at points P and Q meet at the point R with the coordinates 6, minus 1. Part A says show that CPRQ is a square. So first of all, we know that this circle here has centre C, which is going to be 2, 1 from the equation, and it has radius the square root of 10. So if we draw that on the little sketch, this is our circle with centre C, 2, 1, and there will be a point 6, minus 1 outside the circle somewhere here. That's point R. And so we know that the two tangents will meet at R, so those will look something like this. And the tangents meet the circle at the points P and Q. Okay, and we've been asked to show that that CPRQ is a square. Okay, so the first thing we can notice is that the lengths CP and CQ are equal to each other because they're both radii of the circle centre C. And we know that the length of CP and CQ must be the square root of 10. Now we also know that the angles CPR and CQR are both right angles because they are where the tangent and radius meet. And that's one of the circle theorems. So now all we need to do is to show that the angles PCQ and QRP are both right angles, and also that PR and RQ are also both equal to the square root of 10. And one way we can do that is to draw in the line CR. So we get two congruent right angled triangles, and now we can find out some more lengths. So first of all, we can use Pythagoras to find the length of CR. So CR goes from 2, 1 to 6 minus 1. So the lengths of this triangle are 2 and 4. So the length CR is going to be the square root of 2 squared plus 4 squared, which is equal to the square root of 20. Okay. And now using Pythagoras again, we can find the length PR, which is equal to the square root of 20 minus 10, which equals the square root of 10, as we wanted. So we know that these two sides are equal, and also because CPR and RQC are congruent, that RQ also equals the square root of 10. And we also know that because the triangles CPR and CQ are isosceles, that these angles here are going to be 45 degrees, and hence the angles PCQ and PRQ are both right angles as well. And now we've shown that CPRQ must be a square because it has 4 equal sides with 4 right angles. Okay, for part B, hence find the equations of both tangents. So to do this, we can find the coordinates of the points P and Q using the fact that CPRQ must be a square. So the square will look something like this, where we have C 2, 1 up here, and R 6 minus 1 down there. And we know that CR must be the diagonal of the square. So if we find the midpoint of the square, then we'll be able to find the coordinates of P and Q using its symmetry. So the midpoint of the square M is going to be 2 plus 6 over 2 and 1 minus 1 over 2, or 4, 0. So M has coordinates 4, 0. And to get from C to M, we have to go down 1 and across 2. So to get from M to Q, because of the symmetry, we have to go across 1 and up 2. And to get from M to P, we have to go down 2 and across 1. So the coordinates of Q are 4 plus 1, 0 plus 2, so 5, 2. And the coordinates of P are 4 minus 1, which is 3, and 0 minus 2, which is minus 2. So now we have 2 points on both tangents, so Q and R for the tangent here, and P and R for the tangent here. So finding the gradient of the tangent at P, so MP, is equal to, so our point P is 3 minus 2, and our point Q is 5, 2. So the gradient at the tangent at P is going to be rise over 1, so minus 1 plus 2 over 6 minus 3, which is 1/3. And so the tangent is going to be y minus y1. So let's choose point 3 minus 2 here. So y1 is minus 2 is equal to the gradient times x minus x1. So therefore y equals 1/3 x minus 1 minus 2, so minus 3. And that is the equation of the tangent at P. Now for the tangent at Q, the gradient is going to be minus 1 minus 2 over 6 minus 5, or minus 3 over 1, so minus 3. And so the equation is going to be y minus y1. Let's pick 5, 2 for this. So y minus 2 is equal to the gradient times x minus x1. So we get y equals minus 3x plus 15 plus 2. So y equals minus 3x plus 17. And those are our 2 equations of the tangents. Okay, and finally the circled equation x minus 5 squared plus y minus 3 squared equals 20. With centre A intersect a circle with equation x minus 10 squared plus y minus 8 squared equals 10, with centre B at the points P and Q. Part A says find the equation of the line containing the points P and Q in the form ax plus by plus c equals 0. So unfortunately here there's going to be no way to get x or y by itself, so we can substitute one equation into the other. So we're going to have to look for another trick to use. And now here we notice that we only need to find the equation of the line containing the points, and then we're asked to find the coordinates of the points P and Q. So there might be a way to eliminate the x squared and y squared terms to leave us with just an equation in x and y. And to do that, we have to first expand brackets. So for the first equation here, expanding that brackets, we get x squared minus 10x plus 25 plus y squared minus 6y plus 9 equals 20. Now expanding out the second equation, we get x squared minus 20x plus 100 plus y squared minus 16y plus 64 equals 10. Now we can take these two equations away from each other, and we will see that the x squareds and the y squareds cancel. So we get an equation in just x and y, which gives us the intersection points, which is exactly what we require. So the x squareds cancel. We get minus 10x plus 20x, so that's 10x. You get the y squareds cancelling, and we have 6y minus 6y, plus 16y, so that's plus 10y. And now dealing with the numbers, we have 34 on the top row, minus 164 on the second row, so we get minus 130. And on the other side, we get 20 minus 10, which is 10. So dividing everything through by 10, we get x plus y minus 13 equals 1. And taking the 1 onto the left hand side, we get x plus y minus 14 equals 0. And this is the line which contains P and Q as required. Now that was part A. Part B asks us to find the coordinates of the points P and Q. So we know that this line contains P and Q, and so if we look on the diagram, x plus y minus 14 represents this line in red here. Okay, so now to find the points P and Q, we're going to have to solve this equation simultaneously with one of the circle equations. We can choose either one of them. I'm going to go for the first one. So if we rearrange this equation here, we can get that y equals 14 minus x. I'm plugging that into the first circle equation. So we have x minus 5 squared plus y minus 3. So that's 14 minus x minus 3, or 11 minus x squared, is equal to 20. So we get x squared minus 10x plus 25 plus 121 minus 22x plus x squared equals 20. So we get 2x squared minus 32x plus 146 equals 20. Taking the 20 onto the other side and dividing everything by 2, we get x squared minus 16x, and 126 divided by 2 is 63 equals 0. And we can factorize this to get x minus 7, x minus 9 equals 0, so x equals 7 or 9. And so plugging x equals 7 back into this equation for y, we get y equals 14 minus 7, which is 7. And for 9, we get y equals 14 minus 9, which is 5. So our coordinates of the points P and Q. So P has the greater y coordinate, so P is 7, 7, and Q is the other one, which is 9, 5. Okay, and finally for part C, find the area of the kite APBQ. Now to find the area of the kite, we can think of it as being half the area of the entire rectangle around it. So the area of the kite is a half times the length AB, that's the height of the rectangle, and times the length PQ, which is the width. So first of all, we need to find out the coordinates of A and B, which are the centers of the circle. So looking at the first equation, we know that A has to be 5, 3, and the second one, B, is 10, 8. And so the length AB is equal to the square root of 10 minus 5 squared plus 8 minus 3 squared. So that's the square root of 25 plus 25, which is the square root of 50. And now we know that the The coordinates of P and Q are 7, 7 and 9, 5 as we worked out in part B. So the length of PQ is equal to the square root of 9 minus 7 squared plus 5 minus 7 squared, which is equal to the square root of 2 squared plus 2 squared, which is the square root of 8. So our area is half the square root of 50 times the square root of 8, which is equal to 10 units squared. And that is our final answer. And that is the end of chapter 6. I hope you enjoyed.